Hello, everybody. This week, I'm honestly not feeling particularly well, and I've had a fairly dramatic past couple of weeks, and it didn't really allow me to prepare for this as well as I would like to. But we're gonna go ahead and walk through some simple entry-level user-created standard best practices, and time permitting, if anybody makes a request for a UCS for something, and it needs to be simple if we're going to do it, we will build it. So, David Slane and Jim Underwood from the Cabin Vision forums both sent me quite a bit of pretty valuable content, but I don't want to do the information they sent me or them a disservice by trying to walk through that, because I did not really get a chance to review it as much as I would like. But next session, in 2 weeks, we're going to do a much more complete user-created standards video, and depending, we may extend it and actually go beyond the 8 series I was planning on doing for this. So, enough of me talking. Because there is such a great set of help files on this, and because I honestly refer to them so often, we're actually gonna kind of look through some of the help file stuff, and hopefully this will help anybody who hasn't really spent any time at all working with user-created standards. Hopefully it'll give you a bit of a roadmap for where to go to start learning and developing, because honestly the hardest part about getting into this is just getting into it. And what I mean by that is the whole concept of programming or writing code or building a script, or however you want to talk about it, for me at least, and perhaps this is because I didn't have I didn't really have a teacher, and maybe I just kind of went at it the wrong way, I'm not sure. But for me, it was so hard to grasp this concept of really that I'm just creating everything about what I'm doing. And what was really hard about it was the fact that it took me a long time to grasp the idea that with the software provided, which provides the basis for writing the code, there are a certain number of built-in functions, and there are, like, gosh, at this point, probably thousands of built-in parameters. And, you know, I will probably incorrectly use a couple of different terms like expressions and functions, but that's why I'm going to suggest that after watching this video, if you really want to dig in a bit further, you should refer to the help files that I'm going to walk through here, and it will help you out a lot. So right here, just from Cabin Vision, you don't even need to be in the software to access the help files, but I find that when you're learning to write code, it helps to have a little bit of a sandbox area for you to work in. So just having a blank, empty job, and just sort of having that space to build something. And we'll actually go through, now that I think about it, building an empty base object to kind of explore the UCS building, but I don't want to get ahead of myself. So anyway, just having a job file is nice because you can actually test some of what you're reading about, but you don't actually have to have a job file open to access the help files or the user-created standards. So I'm going to jump into the help topics, and So I'm not entirely certain how other people use the help file. I don't think I've seen like an official Cabinavision video or how to. I'm sorry for the pauses. I'm still drinking my morning coffee. You can either go through the contents and really just kind of work your way through exploring all of this, which if you're going to follow the user created standards sort of tutorial training, whatever you want to call it, it's probably the best way to go about it is to actually find the exact area and walk through it. And I'm going to be completely honest, it's been a long time since I've worked through the initial user created standards like practice, but I'll search for it here in a little bit after we go through this so that you can be able to find it. All right, so I don't need to read to you, obviously, but some important things here that I'd like to talk about is dealing with AX, AY, and AZ and the rotation of the part and the orientation of the part is really important to understand, because if you're going to add a part or an operation to an existing part, you have to have a good understanding of how the rotation and placement of everything works, or you're going to get very confused. But that's, again, not really what I want to talk about in this video, but that is a really important foundation. You know, if you're going to add, let's just say something simple like a cutout, some sort of route to a shelf, just for whatever reason. Understanding how the shelf is rotated is going to really help you when you're actually writing the code to place the route on the shelf itself. And so, again, I'm not going to go too far into that, but just know that it can be very confusing when you're writing code for parts if you don't really understand how different parts rotate and how their reference points interact in relation to cabinets and things of that nature. So, in general, and this is not necessarily with user-created standards, but this is just kind of an aspect of Cabinavision. Everything about the software is sort of built on this parent-child relationship. And in many ways, it's basically a great big database with several, like, tables, if you will, or several other databases that are children of the big great granddaddy database we'll call the material manager, if you will, the materials, and the system level. So the system is the highest that you can get, and that's going to be basically where we set up our parts, our material schedules, and things of that nature. Cascading down from that system level is going to be jobs, and then from the jobs, every job will have rooms within it, and the rooms are the children of the job. And every room is going to have walls, and the walls are the children of the room. And every wall is going to have cabinets, and the cabinets are the children of the wall. And then every cabinet is going to have parts, and the parts are the children of the cabinet. And then every part is going to have some sort of operation or something. Not every part, obviously, but most of the parts are going to have operations or hardware or things of that nature, and those parts, or the parts of the parts I just described, the operations, those are the children of the parts. So why is this important? This is very important because when you're writing code, a lot of times you're going to be referencing various aspects of, you're going to be trying to refer to the different parts and pieces that exist within a cabinet, usually. Rarely are you concerning yourself with what's outside of a cabinet. Sometimes adjacent assemblies can play a role, but generally speaking, you're going to be writing your code to do work on parts and operations. But because of the nature of cabinet vision in general and the way that I personally think it should be used, you always want to build what you're going to do in such a way that you can control it from the highest possible level that is practical. So, a good example of this, let's see, accessories. We sell, where I work, we sell a lot of closets, and we do like a bunch of kitchens and other stuff too, and those all have accessories as well. But generally speaking, the types of accessories I feel that you sell in kitchens are not really the same types of things. There's like I don't know, cutlery inserts and things of that nature that you'll sell in a kitchen, but in closets there's a lot of accessories for like the different ways that people like to hang their ties or their belts. So we sell like scarf racks, belt racks, tie racks. We sell jewelry inserts. We sell different types of closet rods, and different poles, obviously. And what I have found is that at least in my area, and I'm assuming this is universal, people like their accessories to match. You don't want to have like oil rubbed bronze poles with brass rods. I mean, maybe you do. I don't know. I'm not very. I'm not an interior designer by any means, and maybe that actually goes together. But what I find is that people want to do, all brushed nickel finishes or all chrome finishes, so that the different accents within their closets kind of stand out on their own, but also match one another. So it's important to understand the parent-child relationship in general of how the object tree and cabinet vision work, because you might most often, to kind of go back to my example, I actually want to set a room finish on all of these different accessories. And so if I'm writing some sort of user created standard to add an accessory, I need to understand enough about the whole parent-child relationship and everything about how this works, so that I can build not only a way to control everything from the room level. And hey, David, I'm not sure when you said that, so I'm a little tunnel visioning right now. Not only do I want to be able to set it all at the room level if I can, because I don't really want to change, 30 different accessories one by one, but when I do have a situation where somebody specifically wants, maybe they want all of their closet rods to be chrome, but they want their valet rods or something like that to be black. Having a good understanding of how the object tree works and the whole parent-child relationship allows you to write code in such a way that you can, for everything in the room, you can make it all chrome, and then you target the things that you want and create overrides on it. And if you guys use cabinet vision the way I do, this will probably sound a lot like the differences between setting a job up and then having your different rooms within that job that have different finishes or different materials, right? Maybe you're drawing a big house with 15 different rooms, and you know that 10 of the 15 rooms are going to be a specific stained finish. So you're going to set your job up to have that stained finish as the default. That way, most of the rooms out of that home that you create, you don't have to go in and modify each room setting individually. Only the ones that are not that specific stain color will need modifications. So the two scenarios I just described are really very similar, in that it's extremely important to have a good concept, a good understanding for how the parent-child relationship works throughout cabinet vision, so that you can be efficient with your work. You really, again, to iterate this, you would like to, I like to at least, always make changes at the highest level that is practical to do. But you always want the ability to override what you've done you know, a bit lower. Again, you might want to set the room up to be something, but you sometimes need one individual something that's different from the entire room. So anyway, that's, I know I said a whole lot more than you'll see here in the help files, but the object tree is really important. Take some time to really understand it. And just to kind of talk a little bit about this in case you've never actually used the object tree, rather than kind of using the help file, I'll just walk through this just a little bit. So when you're in the object tree, as far as I understand, it's not possible to ever actually see the job, which is probably for the best. But each room is going to have its own object tree, and then within that room, you'll have different walls, and obviously, you should have, in theory, different things on different walls. And this is obviously not something anybody would build, but I'm trying to kind of demonstrate. So, again, we've got a room. And within that room, I've got all sorts of different attributes for various things. Some of these are room notes for one of the previous videos that I recorded, but for the most part, these are various things that will control, as you can see over here, different things about how I build. So I've got like a room floor system setting here, for example. And this is for my closets. We call a floor system when the closet actually rests on the floor. That's what we call it. So this is a great example of the different ways that you can set something at a high level, but then control it individually at lower levels. So I'm not gonna waste everybody's time watching me do this. Oh, that was interesting. Kind of wondering if I've got my UCS is turned off. Anyway, so long story short, a lot of times with closets, you'll do, to save the customer money, you'll want to have a bunch of what we call like half panel systems. Sorry, I don't draw as much as I just use, and I'm really thinking that I've actually I think I turned off a bunch of my stuff here, as I don't normally do production work in 2022. So anyway, yeah. So this would be the difference between a half panel and a floor system, right? A lot of times we draw entire rooms half panel and you have just one section that is actually a floor system, like variation of how we build closets. And as you're writing code, a lot of times you'll need to write it in such a way that the assemblies or the parts or the operations or whatever it is you're working with will follow the room settings, but you want to, at a lower level on the object tree, control an attribute that allows you to modify the assembly in specific ways. So I'm gonna try to find this again. Here we are. So, right, this would be an example, basically, of, I've got like hanging, like clothes here, but this section here in the middle, I might have like drawers and a hamper or something like that. So what does that look like in the object tree, which is the whole point of me even going down this. I'm on wall 1, on the front face. So I'm never going to be able to find this attribute because I have so much crap going on here. But basically, the override that I created on that cabinet was at a lower level than the room. And so the original UCS that I wrote for each assembly, rather than being set up by default to look to its parent for instructions for what to do, which is the room, right? The cabinet would be looking to the room, its parent in the object tree, to know whether it should be a floor system or a half panel system. If any set of instructions in between the assembly and the room defines what the assembly should do before the room does, the assembly will stop looking up the object tree if you write your code in a certain way. And that would be basically by telling what you've written to simply look up the object tree to find the answer, as opposed to very specifically telling it to follow itself and only itself. And that's kind of a confusing thing for me to say, and I'm questioning whether I should have even done this today because I'm not feeling super well, but that's okay. We'll get through this. So again, learn what these different parameters, learn what they mean. You have to have an understanding of these very, very basic concepts, or you will never be able to even begin to write the simplest of code. So, the 9 basic parameters that every part is going to have to do with placement, rotation, and size. Without these basic 9 parameters and a good understanding of them, you're not going to be able to write very much with your code. I'm going to try to find the I'm going to try to find the lessons. Sorry guys, just a second. Hey, Jim or David, do either of you guys know what a good, basically where in the help files the UCS introduction lessons are? Samples. I feel like this is really not in the place that I think it should be. Oh, I bet it's here under parametric editing. That makes sense. Okay, so if you're looking for basically a tried and true way to just get into writing UCSs, this is the place to go. Unless you're going to hire somebody to sit and teach you and work through a specific problem you have, because that in many ways would probably be the fastest, best way to do it. But if you hired me to teach you, we'd sit down and go through at least one of these exercises, depending on what you were actually trying to do. If you had a really complex problem that you needed to work on, then having us sit together and go through it would be meaningless. You wouldn't learn anything. But yeah. So going through these different exercises is going to be extraordinarily helpful for anybody trying to understand it. And they're going to talk about these, again, the 9 basic parameters, the positional ones, rotation. This is going to teach you a lot of the stuff that you will need to have a foundation of knowledge of understanding before you should even try to jump into writing code, or you'll probably end up doing a lot of this. You'll probably end up making a lot of the same mistakes that I did. Like, let's say, for example, I, at one point, because I have this tendency to just try to go faster than I should when I'm trying to learn. I didn't read through everything in the help files the way I should have when I was learning. And at one point or another, this is when I was working for an architectural millwork company. At one point or another, I was trying to basically... I had assemblies that were going to be angled fairly often, and so I decided I'm going to be this clever guy, and I'm going to write some code to figure out what the angle is on the left and the right ends here. And don't get me wrong, it was a spectacular exercise in learning. And I actually developed this really, really nerdy obsession with right triangles as a result of it. By the way, if you don't know, right triangles are the coolest shape ever. You can pretty much figure anything out if you can break down what you're working on into right triangles. It's insane what you can actually do if you start looking at everything about your shaped assemblies as a right triangle. You can figure out some really incredible stuff. But anyway, not to tangent too hard on that. But anyway, I basically was trying to figure out, how do I calculate the angles of my two ends? And I feel like there might even be something on the actual cabinet itself. Maybe not. But what I can tell you for sure is, rather than doing a bunch of math to try to figure that out, if I had just taken the time to click on the left end and really understand, it tells me the angle. Whatever this thing is rotated at, I have the angle. And then not only that, but I also have miter left and miter right values. And so all of these things together gave me everything I needed without going through that convoluted mess I did to try to figure out what the angles were on these. So I'd say the first thing, not the first thing, just a good thing to keep in mind once you do start exploring writing code is check to see if it's already been done. You don't need to reinvent the wheel. Try to break down what you're thinking about doing into the simplest words you can, and then do a forum search, or even just kind of search through the system parameters to see what types of things exist to help you along your way. And it seems like with each iteration of cabinet vision, they tend to, or it seems like at least, they're introducing additional parameters, sometimes modifying the way the parameters that exist work. And David apparently is a fan of isosceles triangle, but that's okay. We can be different. Let's see. So this little article, if you will, is actually really, really helpful. For a long time, I spent a lot of time struggling to really get the AX, AY, AZ stuff. And forever, I used to rotate everything in the wrong way. Anytime I tried to rotate a part, I would have to do it at least twice. Which is not always true because, mathematically, I should have guessed correctly at least half of the time, but it felt like I never did. So thinking about AZ as the propellers of an airplane and thinking about AY as like a tether ball, and thinking of the AX as I don't know, this is a little bit absurd, like this guy's gonna swing around, but just reading through these descriptions of how the AX, AY, and Z parameters actually do rotate parts is helpful. And then just the knowledge and understanding that, like, to rotate clockwise you go negative, counterclockwise you go positive, is also a really good thing to just know. So I don't want to bore myself and all of us by going through these little things here. A lot of this is very basic, and I don't feel like anybody... I don't feel like the majority of people who have the capacity to learn to write user-created standards need me to read this to them, to be completely honest. Some people might, and that's fine. And if you are watching this in the future and you're like, man, I wish that he would have helped me understand this concept about this little thing in here, just reach out to me. I'm not trying to shame anybody if they don't really grasp this the same way I do. In fact, I don't really expect most people to think about anything the same ways that I do. So we're all different. And if you're struggling to understand anything about these different sort of basics, just send me a message and we can work through it together. And then same thing with these exercises. Take the time to go through them. If you are the type of person that you're just going to cram and go through all of them in one sitting, I applaud you. That's honestly quite impressive that you're going to do it that way. But slow and steady wins the race with any type of programming language that you're going to learn. I really and truly believe this. I have at least 2 or 3 times now just for lack of a better term that I know of, sorry, I don't mean to be offensive or anything, but just totally cracked out on learning some sort of programming language for just this block of like 6 or 8 hours. Also, I can get to the point of being able to do something that I needed to get done. And because I did not keep up with it, it's gone now. I don't remember, how I did it. Whereas if I had just kind of slowly and steadily over time consistently learned and reviewed the lessons that I was working through, I mean, kind of like school. I don't know. School was such a frustrating thing for me in so many ways, but there's a lot of wisdom in the way we are asked to review things and go over them again and again. So I really cannot stress enough how important it is for you to just slowly and surely read through each of these, work through each of these if you can. And what I would caution anybody who is not a business owner, who is not a manager of the software, if you're just joining a team and you're wanting to learn how to do this kind of stuff, you really need to ask whoever is the most senior with the software before doing it. Because if you don't, you're going to upset some people. Because one of the things that I think is really bad about these exercises is, like, right here, first exercise, page 1. They're like, go in here and change your standards. Don't go in here and change your standards if you're working in a production environment. Do not do this. It is terrible advice. Yeah, again, this is really worth focusing on. If you are trying to learn how to write code and it is not your database, it is not your system, and you're working in cabinet vision and you're going through these exercises, talk to the person running things where you're working. Ask them how you can build a test environment for you to work in so that you're not making changes to your production database. So, now that that's kind of like beaten in, this is a really important one, and I realize I kind of skipped through all of this, but troubleshooting error messages, something that I really just kind of, again, spent too long just like being that guy that just clicks through things without reading them. For a long time when error messages would show up, and this may have basically, maybe this is because, you know, when I was learning how to use computers way too long ago, the types of warning messages or error messages that I encountered in Windows were so far beyond my ability to comprehend anything about what was going on. There was no point in me reading them, and I probably built, you know, bad habits as a result of that. But I find oftentimes when I'm working with people, they'll tell me I had an error message, and I will ask them, what did it say? And usually I get this deer caught in headlights look followed by an apology. I'm sorry, I didn't read it, I just clicked it so it would go away. Don't do that. When you are testing your user-created standards and you think you've written something that's going to work and you're going to go test it, if you get an error message that pops up, take the time to read it and understand it as best you can. Because it's going to be the only way for you, unless you are particularly savvy with programming, to debug what's actually going on. It's the only sort of built-in debugging that Cabinet Vision offers. So I will actually give you an example here. So a lot of times when I'm writing, I try my very best to be very slow and take my time. And as much as possible, when I'm writing new parameters, if I have to type them very often, I try my very best to actually not type them, but once I've done it the first time, copy it and paste it. And as a short little aside, somebody on the forums, I don't know who it was, so sorry, whoever you are that I'm not going to credit correctly. What I'm doing right now is I'm just copying over and over different things, right? And I think this has existed forever, but I didn't learn about it until recently, and now I use it all the time. This is such a cool feature. Actually, I don't even know what the heck that is. So I believe Windows, yeah, no, sorry. It was exactly what I was expecting it to be. I just was copying things in such a stupid way that it was confusing. Let me start over. So let's just say that ACC cab type is something that I'm trying to copy and paste over and over. And then, you know, this is something I might need to copy and paste over and over later. And then room name is another one. If you press your Windows button, which is between Control and Alt, and V, you get a history of your clipboard. So if you can get into the habit of copying your parameters so that you don't retype them and typo them, which is what I'm trying to talk about in general, the use of this tool will save you a lot of time, because it's just really fast and easy to recall things that you've copied, right? So I don't know what I might have screwed up there, but let's just say that while I was writing this, I'm working my way through it, and when I ended this line and I meant to close my quote, I didn't. I didn't push the button or whatever, right? I typoed. I click close. Yeah, I want to save my changes. This is the warning message I'm talking about. I even just now had this urge to click OK, probably because like I know what's wrong. But what this is telling us is rename cabinets for scenes. This is the name of the UCS in that list of user-created standards that we were just looking at. This is the name of the UCS it's referring to. It's telling me that on line 11, there's an unexpected end of string. So if you've been watching the other videos, I've talked a little bit about the differences between like strings and values and whatnot, but in programming, a string is basically a list of characters or numbers that you typically cannot do like math on. So it would be like a word, or, you know, like a Hayfela product number 192 dot blah 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 blah. That would be like a string of information. So this is saying there was an unexpected end of string on line 11 in the UCS rename cabinets for scenes. If you just click that before reading it, now you get to go back into your UCS and try to figure out what actually is wrong. But I know that because I read it in my rename cabinets for scenes UCS on line 11, there was an unexpected end of string. So because I took the time to kind of like look and read and comprehend that warning message, I can very quickly solve my issue. So let's just say that, by the way, now I can come back and like rebuild my job so the UCS runs and I don't get an error. I know I've corrected my problem. I don't know that my UCS is doing what I want. That's a totally different thing. But I know that I don't have some sort of syntax error or structural issue with my code that will prevent it from ever being right because I'm not getting a warning message. Now, to kind of recreate this, right? Let's just say that we have the warning message and we clicked it real quick and we're like, crap. All right, well, I'm gonna rebuild, right? I'm sure I'll get the message again if I just rebuild. No, you won't. So, okay, maybe I can go back into the UCS. Right, if I edit it again and come out, it should tell me that same error message. It totally doesn't, and it sucks. It's really frustrating. Although if it was otherwise, I might actually say, stop bombarding me with that stupid message if I don't need it. But there is a way that you can get that error message to come back. And this is a really useful thing if, I mean, I don't know, people end up in weird places in the software for some reason from time to time. I've had people accidentally modify UCSs for whatever reason. But let's just say that somebody told you, hey, I accidentally got in somewhere, I didn't mean to be, I spilled coffee on my keyboard or whatever, right? Things happen. To get that message to show up again, it's really, really simple. All you have to do is just make some sort of modification to the UCS that you know for sure isn't actually going to cause a problem. So the simplest way that I know of to do that is to just put a semicolon somewhere. At this point, we've modified the UCS. It's going to require me to save it again. And so what I think happens here is when you make an edit, it gives the UCS an opportunity to display warnings again. So now all I really did was add a semicolon, but because of that, I get this warning message back so that I can once again try to track back to wherever it is in my code that I messed up what I'm doing. And when you've got a UCS that's like 21 lines, who cares for the most part? I mean, I do care. I think efficiency is important, and we always want to be able to backtrack and figure out where we made a mistake as quickly as we can. But with something this small, I could probably scan through it and figure it out pretty quickly. But imagine if you had, you know, a much longer UCS. Here's my cabinet attributes UCS. So this one, because I am doing like a lot of different things for the tag hardware collection, you know, this one's nearly 700 lines, comments included. If you don't have a warning message helping you find that string, like which one? This is going to be a nightmare to try to track it down. So it might seem obvious to most, but slow down. Really, really, really slow down and just be very, very intentional as you try to learn to write your code. And you're going to get less frustrated as a result. And I believe personally, you're going to learn. You're going to learn a lot more that way. Sorry, I got a little distracted. So I want to talk a little bit about some of the things that David and Jim have mentioned, which are definitely best practice for sure. So if you happen to be working in a standalone environment, you're a little safer with this. But if you're on a network version, actually, to be completely honest, I have not worked in a strictly network environment. I was in a hybrid environment for a while, which was sort of this combination of, we had standalone databases, but we all looked to the server for some information. It was a little faster than network, and it gave us some flexibility. But basically, in that environment, if I made a change to the UCSs, it would affect everybody's computers. And that's a problem. And if you're testing a UCS in an existing job and you don't put some important filters in place, you can cause some problems. Kind of a little anecdote, I guess. A very near and dear friend of mine who I met while I was working at my last job in California, who actually came over to Vegas with me to work where we are now. He was, I don't remember what we were doing. But he's a particularly bright guy, and I was trying to take the time to teach him some things. And long story short, at one point we had this job, and I accidentally renamed every single cabinet and every single part in that job Beech. And to this day, we joke about this like all the time. And it was such a pain in the butt to go back and revert. It was a mess, right? And I'm sharing this. I'm sharing this because I'm trying to point out how important it is to make sure that you are testing in an isolated environment. Yeah, literally all of our parts were named Beech, all the shelves, all the everything. It was a mess. It was a good lesson. So, how do you do this? There's a couple of really easy things that you can do to make this work out. But basically, okay, so before I get to that, a couple of really, really, really important basic things about writing UCSs. This top line here, that is a comment. It doesn't necessarily like have to be a comment, but whatever you write here shows up under the description. So if you've got a bunch of user created standards, it helps to have a nice description here of what they're for. And years ago, I think a lot of us used to try to keep as few UCSs as we could and make them these like really great big UCSs that kind of worked on everything. But I think at one point Jonah determined that you operate a bit faster if you try to break them down. So for me, that meant that I can no longer open up my great big cabinet parameter UCS and search for the parameter or whatever I'm looking for and find it. Now I've got to kind of sift through my individual UCSs. And so having a good description and a good name for your UCS, along with some good organization and categorization, is really helpful. And so that's what this first line kind of does. Just a semicolon will create a comment, which is just basically code that does not actually get written or do anything. And on the first line, it's going to create a description for you. A couple of other things before I get to the point I'm trying to make about how to work in an isolated environment, just since we're here. I personally, I really like having line numbers. It helps for a lot of reasons. First of all, with the warning message, if it tells you what line you're on, it's nice to be able to read which line so that you can navigate to it quickly. Two, if you're working with anybody else on a code, on a script that you're building, or if you're teaching somebody or troubleshooting or whatever it is, right? If you're not driving, you're navigating, as I tend to say, and somebody else is sitting at the computer and they're the ones driving. How do you refer to anything if you don't have a line number to go to? So I think it's really important to have the line numbers on if you're going to use this default UCS writing environment. I recommend using Notepad++, but I don't always write in Notepad++. And we'll talk about that next video. But anyway, so really important, I feel, to have the line numbers turned on. And then I guess really that's it as far as just basic settings here. And we'll talk about these different buttons later as well. So the first line is a comment, as I said, and it creates the description for your UCS as you look at it. The next thing that really comes in a UCS after that, or really the first line that does anything, period, anything at all on anything in your job, is what we refer to as the for each line. Right? For each. So this is the for each line. You can only have one for each line. You can have a lot of things in your for each line, but you can only have one for each line. Now, years ago, and I think this might still be true, you cannot have a UCS with a for each line that is for each cab assembly that also targets parts. I think that is still true. I'll verify and confirm in the next video, but what I mean is if you've got a UCS that you're writing for each cabinet, you cannot also target individual parts. So let me jump to like a part UCS to kind of, let's see, no, okay, so no, this is another cab assembly. Here. So this is a UCS for a bunch of different parts, right? It's for adjustable shelves, fixed shelves, unfinished backs, tops, decks, bottoms, you know, on the left and the right front, boring, and then part, right? So you can have many, many, many parts in your for each line, but you can only have one for each line. So, oh yeah, so David is mentioning, just in case you're I really need to just like get the stream chat probably displayed. I'm going to try to do that for next video. But basically, so David is saying that technically cab is a part, but behavior on cab parts is unpredictable, and so it's best practice to kind of isolate them from one another. And he's also talking about door, and I think DWR probably falls into this category as well. So the DOR part, quote unquote, and the DWR part, they're not only parts but also like assemblies. And so anyway, long story short, try to write your UCSs for your parts separate from your UCSs for your cabinets. And most of your for each cab assembly lines are really going to just be that. But when you start writing a for each for your different parts like this, you can actually have it targeting a bunch of different parts, so that you've got one UCS that's going to do a bunch of, well, maybe not a bunch of stuff. It's going to do something to a bunch of different parts. And then as you work your way through what you're writing, you're going to filter the different parts out. And again, we'll talk about that later. This is mostly just about the for each line. So if you wanted to write a UCS that did something to both fixed shelves and adjustable shelves, you do not write two for each lines that read for each adjustable shelf part, for each fixed shelf part. You include that in the same line, and it's like for each adjustable shelf, fixed shelf, and you separate them with these pipes. And you can list several different parts in your for each line and have it target your different parts. Oh, drawers assembly only is what David is saying. So I'm not even going to talk about that, Jim, because it's a good thing to know about, but we'll talk about it a bit later. But basically, Jim's talking about wildcards in the for each line to target a variety of different things. And in a nutshell, it's very powerful, but if you don't use it right, you're going to really slow everything down, and you maybe name everything Beech. So anyway, back to this, right? So once you have decided what you're writing your UCS for, so you've got your description in your first line, and you've created your for each whatever, there are a couple of different ways that you can really isolate what you're doing. You can basically set it up so that the UCS won't run on anything unless you add a very specific parameter to a job, for example. So you could do that by basically saying, like, let's just say that I want my job parameter that's going to turn this UCS on or off to be UCS test. And the way you could filter for something like that would basically just be to say this, not even this. So if UCS test equals null, then exit. So what this has basically done is before anything happens on any cabinet that would be targeted by this assembly, every single cabinet is going to look for the parameter UCS underscore test. If you have not created this parameter somewhere in your job, which means it will be null, then it's going to exit without running any of this code. So if you're just here learning UCSs and you've literally never ever written any code, this is probably still a little bit advanced, but hopefully you can follow the idea that we're creating a filter here. We're creating a way to isolate everything. And to take this just a little bit further and kind of refer back to the conversation we had early on about the object tree, because I did not specify what must have UCS underscore test, every cabinet is actually going to look first to the wall that it resides on, then to the room that it's in. All right, if we want to be really, truly technical about this, first the cabinet's actually going to look to the wall face, then to the wall, then to the room, and then to the job. And really, ultimately, after that, to the system. So what this means is I could have individual rooms where I add this attribute, this parameter, and some rooms would allow this UCS to function while other rooms would not allow this UCS to function. Or if I wanted this to work on every room in the job, I could simply add this parameter to the job level, and then every cabinet in that job would eventually work its way up the object tree to ask the job, hey, do you have a UCS test parameter? The job would say, yeah, hey, cabinet guy, yes, I do. I have UCS test. You can go ahead and do what's after this, right? You've passed this gate, this filter, if you will. Yeah, so David clarified, right? First, the cabinet's actually going to look to itself. Then it's going to look to its parents. So you could even add this attribute on the cabinet itself, and only that cabinet would be affected by the UCS, as opposed to all of the cabinets maybe on that wall or in that room or in that job. So when you're testing, and I've got my UCS list is embarrassingly messy right now. I've done just a lot of messy work with my 2022 since I've been doing the AMA thing that we're trying to do here, and I have a great big cluttered mess to clean up. But it's what was I going to say? Jeez. I don't know. I lost it. I lost what I was talking about. I apologize. But yeah. So this filter here, this concept of the filter, this is actually really, really important. And I'm going to talk a little bit more about this and then probably wrap up the stream and probably take a nap. But basically, this initial filter to keep everything isolated to a test environment. Oh, that's what I was going to talk about. Sorry, going back down the same path. Normally, I actually keep a test UCS or 2 or 3. And they're literally called like test UCS, and the first lines of that UCS will just be for each cab assembly or for each asterisk part or whatever it is. And then I've got this set up so that it's really simple for me when I need to test something. I just jump right into one of those UCSs. I wipe out whatever code I had in there before, because it doesn't matter, because it's just a test environment, and start working within that one. It's just I don't know, sometimes small hurdles for me present much larger problems than they should, and creating little simple kind of solutions like this, if you're a Paul Akers fan or a lean manufacturing freak like me, it's a 2-second improvement. And when you test UCSs on the regular, those 2 seconds add up, and it makes a big difference in your day and your life. And so I feel personally like having this sort of there and ready for you not only helps get you in the habit of testing things in an isolated environment, so again, you don't name everything Beech and have to live with it. Get in the habit of doing this, and it will save you a lot of time. So anyway, the point I wanted to talk about before buttoning things up is basically this if condition, then do something, and if is the basic structure of like everything UCS writing in cabinet vision. it is essentially, and I'm sure there's a programming term for this, perhaps somebody who's more formally trained will share, but basically, we're saying over and over and over, if something is true, or if I mean, really, if something is true, then do things. And if, right? So we're looking for conditions to be met to sort of like open these logic gates or doors or whatever you want to think of them as to whatever code you're going to write after that gate. And so I kind of tend to think of these if, condition, then statements as like logic gates, right? So to work down this very, very simple UCS that I have from the last video, right? My first gate is checking for every cabinet, is your class parameter equal to 1? I probably didn't need to do that because I've got this here. So real quick, system parameters I use all the time, like all the time. And it's this massive list, right, of all the different things that you can do by default. Not all of them, just the ones that they want us to use. If you search for system parameters and then you select it, you double click it, right, so that it's here, and you switch over to favorites and you click add, you will have it here ready for you immediately. And if you have topics that you go to regularly, I suggest adding them to the favorites. It's just, again, one of those little things that'll save you a tiny bit of time. So I wanted to look at class. This parameter, this system generated, system supplied parameter will reference the object's class, and it's just an integer value between 1 and 23, right? So if the cabinet's class parameter is equal to 1, I know it's a base cabinet. So to kind of go back to the UCS, right? If cab.class equals 1, then, and you'll note over here I've commented, because even today, after doing this for as long as I have, I don't remember. Like I can not ballpark, I can like guess kind of, but I don't have these values memorized, and I don't recommend that you waste the brain power memorizing them. So, but I do want, when I come back to sort of troubleshoot this or do some upkeep, I don't want to have to go and search the help file again to understand what it is I've written here. That's why having a comment is useful, right? So if cab.class is equal to 1, then I know it's a base cabinet. This is just the same basic thing as what we wrote up here as our gate to prevent any assemblies that we don't want reading this code from reading them, right? So if this particular condition exists, or if this particular condition is true, then I want you to do something. And the way the structure generally works is after a then, any part or cabinet or whatever that makes it past this gate will do everything listed until you come to another conditional if, like gate or while, until you either until you run into an else or an end if line. So basically, right, if the cabinet's class is 1, then make this parameter exist on yourself. And we'll talk more again about, like, this is basically one of those concepts I was speaking about early on that was outrageously difficult for me to comprehend at the start when I tried to learn how to code, was the fact that I'm just making things. Like, I'm just creating parameters that are gonna do something at some point. That's all I'm doing here. I'm just making this parameter, and we used it down here, right? I made it here so I could use it here. Anyway, after this logic gate, the cabinets that pass it, if you will. Every cabinet that is cabinet class 1, it's going to do whatever you tell it to after that initial line. And then it's going to actually ignore all of these other conditions here that are else's until the end if. So basically, it's going to go from right here where it passed its gate, it's going to do what we tell it to, and then it's going to just ignore everything else until you get to the matching end if for it. So that's the really, really poor explanation for why upper cabinets are not being named base, or really why base cabinets, after we name them base, are not then just being named upper and then being named tall and then being named closet, right? Why does the base cabinet not just go through all of these things? Because it already, at this point, its criteria was met. It's like, all right, I did what I'm supposed to do. I'm out of here, guys, later, right? It made it past the logic gate, it did what we wanted it to do, and then it just went to the end and chilled out and relaxed and, you know, waited for all of the other cabinets that are going to fall into these other categories to get their things done to them, I guess. Probably hopefully it's a somewhat comprehensible way of explaining it. But it does essentially boil down to nothing more than you're going to write a bunch of filters to narrow down what you want to target before you even start doing anything to it. Having a strong understanding of how to build good filters is going to be extraordinarily useful, because you know, the name of the game and what most of us do is speed and accuracy. We want to produce drawings or build cabinets or whatever it is that we're doing with the software as quickly as we possibly can without hurting our accuracy. Never for the sake of accuracy, right? So if you write your filters well, if you create good logic gates, you're going to eliminate the slowdown that user-created standards can impose on your system by reducing the number of operations and calculations that even need to occur. So basically, this is a really, really important concept for you to understand if you want to build complex UCSs that don't slow everything down about what you do. You want to have as high up on the list in the UCS as you can the bits of code that are going to target the greatest number of things, and then you want to exit as quickly as possible. So strong logic filters, strong logic gates to isolate what you're trying to do specifically to the part or the operation or the cabinet or room or whatever that you want to do is a really crucial foundational thing for writing user-created standards. And so at this point, I'm going to kind of just review a little bit of what's been going on in the stream chat so that anybody who is watching this video later that didn't actually watch the stream can kind of get some of this, right? So one of the things that Jim mentioned as a good pointer as well is the nesting of the code. And basically what he means is after you kind of create like a logic gate, the next line for the things that pass, if you indent, if you tab, or if you like using space instead, that's okay. I see merit in the space when you've got really, really long lines of code or a lot of nesting going on. But otherwise the spacing just kind of annoys me. I feel like tab, for my eyes at least, creates a greater obvious indentation, which helps my eyes follow the code a lot better. But basically, Jim says, get in the habit of nesting the code as I've shown. If you do, you can follow the logic much more easily. If you get sloppy in a big UCS, it starts getting really hard to decipher. So this is not a large UCS, but I will kind of take all of the formatting away from this just to kind of try to demonstrate what he's saying. So the way that this is all nested can potentially be a little bit confusing. So I'm actually going to kind of rip this apart. So basically, this is the very last nested statement, right? So after all of these other conditions have not been met, if it still is not one of these things, then we've got one final action that's just going to happen to every single cabinet that does not match one of these various logic gates that I've produced. But basically, we've got this indented in such a way that the line starts here, where we're filtering for cabinets that are class 21, 22, or 23, and we're doing something. Otherwise, there is no other if, right? So if it's not this, if it's made it this far down and it's not cabinet class 21, 22, or 23, then just, right, this line of code, we're not talking about what's happening here, right? It's more about the gates and the indentation. What's important to notice here is that if you look vertically right here, these lines all start on the same indentation. And what this tells me is that this opening of the logic gate, if you will, only lasts, so it starts at line 17 and it ends at line 21. If this end if was over here, I don't have an easy way here to just kind of like move my eyes up and down my code and understand where my statements are starting and stopping. So the indentation is really, really useful. And now at this point, I can basically, at a glance, I know so frustrating. Right? I took that like nested chunk out from what I was doing, and now I can sort of look up and down again and see that on line 14 I opened up a logic gate, I did some things, and then I had an else statement in here where I must have had some code at some point, but I took it out, right? I stuck it down here. So then again, this is kind of like another like nested like block of code, if you will. And then again, now that I've taken this section of nested code out, we can see very easily looking up and down that I start here, then I've got an else, and then I end. And without even taking this out, I'm sure at this point you can kind of see if, else, and if, right? So the indentation of your code is going to make everything about what you do a lot more readable, as opposed to, we see this on the forums from time to time, and it's really, really hard. Like, right, just looking at this in and of itself, 4 lines one after another of end if, end if, end if, end if. If you don't know anything about writing code, this is the most confusing, like, it's just very confusing to look at if you don't know anything about code writing. And if you do, now we're spending a bunch of time trying to count how many ifs there were, right? Which end if does this refer to? Well, it's the second end if in the list, so I'm going to count up. There's 1 if, there's 2 ifs, so this end if is for this one, whereas before, with the way it was indented, it was really, really easy to tell at a glance. And then I will just share this other kind of pointer from Jim real quick. Actually, before that, so one other important note somebody mentioned is it's good to know, it's good to nest your code the way I've shown for readability, but it doesn't matter. The code will run either way. You're not going to end up with some sort of error on this code just because there's no indentations. Right? If it's formatted like this, it's still going to work. Right, this is still naming this room 1 base cab 1 or whatever. I'll grab another cabinet and just show you guys, right? It's still, when the UCS runs, it's gonna run. Oh, I don't have the code. Here, let me just take this out. So you guys just got to witness, right? Because I put this filter in place while I was carelessly trying to jump in and test it, it didn't work. So really important to have those filters there and take your time. That way you don't like accidentally do things you don't want to do. So again, right, room 1 base cab 1, it's working. Regardless, it's working. Whether it's nested or not, the code will still read, it'll still run, it'll still process. It's just harder for you later. Yeah, Jim was just an error message, right? If we missed an end if, here's another warning message. This one doesn't tell you what line it is because, I mean, I don't really know the exact logic for why, other than just to say that I think it got to the end of everything, and as it was expecting to end and find one last end if, it didn't, right? And so that's what that means. Unexpected end of UCS. It made it all the way to the end of the code and it had nothing else to do, but it was still in an open if statement. So if you get this error message, you need to go find somewhere that you left out an end if or accidentally commented one out or something like that. And then a couple of help files that are really good to have saved per Jim here. The system parameters, as I've got here, and functions and operators is another one that Jim likes, which I agree. So this one is going to basically show you all of the different things that you can do to stuff. So adding, subtracting, all of these things. This is going to explain it. And while we're here, I didn't learn about modulus until, I don't know, maybe 2 years ago. This is such a cool function, or operator rather. I really, really, really like when I end up with opportunities to use it, because it's such a strange, sort of unique to me. It's like I learned some kind of, I basically learned a new math thing, and like addition or subtraction or multiplication or division. And so the modulus parameter basically gives you remainders, and it's really cool. So I don't know if you are bored and you want to look it up. This is a really cool thing to learn about, and it helps you solve interesting, unique problems when you're writing code that otherwise feel kind of like impossible to work through. But this also gives you some good information about creating parameters and setting their styles and stuff. Very, very useful. along with the different functions that you can utilize. And then the other one that Jim recommends is a breakdown on UCSs. And this one does have a lot of really good, just general information about, like, I mean, there's a lot to it, right? And there's a few different examples of what you can do with it, and the different object types that you can use in your for each statement. So these are definitely a couple of really good, these are 3 really great topics to have in your favorites tab for quick access. So all right, one more. I love it. So Jeremy has suggested internal part names as a good one. And he's absolutely right. So the good thing about this, right, you can access all of these part names in a different area. It's basically here at the splash screen, right? It's part. Just shut that off so I don't deal with that. So this help file here that oops, grabbed my OBS there. The help, what? Why are you doing this? There we go. So all of these different part names are really listed over here as well. But you cannot work with any UCS while you have this list open. So having the help file, you know, probably like up on your other screen or something is what I would recommend. Having this help file up while you're writing your UCS is going to help you target specific things. And not to take too long with this, but this also kind of breaks down the object tree for you so you know how to navigate to that part, right? I don't know anything about face frames. I'm not a frame guy. I've worked for just a short 18 months at a shop that did framed cabinets. Thank God. And so I don't really know anything about where in the object tree face frame parts are, but this help file tells me this would be cab.face.frame.rs, if I'm not mistaken, to get me to the right style where I could access the right style's parameters, right? I'm assuming that's what that is, but I know that like cab.case.lf is absolutely correct. Cab.case.interior. No. Yeah, I don't know. I might be giving you bad advice there, but for sure, this is a really great way for you to look at the different parts while being able to stay in your UCS and keep writing without having to jump back and forth, which is really, really irritating. So yeah, last but not least, if you are planning on attending the next one of these that I do, which will probably be another really long one like this one was, I'm going to try to talk a little bit more about Notepad++, but in general, and maybe somebody else actually already has this. If they do, that's great. But I use this all the time for all kinds of different things. But I took some time. One of the cool things about Notepad++ is it supports all sorts of different codes, all sorts of different languages rather. And when you write in those languages, it highlights keywords and things of that nature. Kind of like how when we're writing a UCS, the end if and the if is blue, you know, comments are like this kind of like green color, the rest of the code is white or whatever, right? This is useful to have the different aspects of your code color coded to help you find what you're looking for as you're working through it. Notepad++ comes by default with all sorts of these different languages that you can select, but you can also define your own language, which I have done a little bit of, and I think somebody else might have actually done one that's a bit more complete. But basically, to just show you, right, I switched this language to Cabinavision UCS, which I created. I'm going to go back to like normal text, and notice how much harder this is to read versus having it set up so that it kind of color codes everything the way we're used to seeing here in the UCS code writer. So I recommend getting Notepad++. It's free, and I will take just a tiny bit of time to search and see if somebody else has done a more complete Cabinavision UCS like language definition. But because it's there's a lot. It took me a while to go through and set this up. It's kind of involved, but I'll share what I've got if I don't find a better one, and I definitely recommend using it. It's really, really useful. So sounds like Jim's got some. What do you know? All right, guys. It was a little bit of a rough stream. I was definitely having some focus issues, but hopefully if you're new to writing UCSs, this was a good sort of like whetting your appetite for what you can do here. And if you've been writing UCS for years, thank you for kind of pointing out some of the obvious things that are best practice that I didn't talk about. And really, there's so much to this. This is such a vast topic. I've been writing UCS for quite some time at this point, but I still really feel I feel very amateur with it in so many ways, to be completely honest. It's I see some of the things that some of you guys write, and I'm floored. I cannot believe how elegant some of you guys are able to get this stuff to behave. And I'm just saying this basically to I want to drive home the point that as good as you get with this, as much time as you spend with this, the learning doesn't really stop. As Cabinavision actually allows different things to be introduced into code writing. Recently, they allowed us to start writing loops. Before we could write while loops, it was a lot more cumbersome to write some of the more complicated, involved scripts. I think I took one of our... So, without going into this too much, this sort of like database of Cabinavision has been going for us at this company since Cabinavision 3 point something or so, in some form or another. When version 8 released, I kind of rebuilt the system for this company for version 8 when they switched from 4.2 to 8, and then I'm actually going through another rebuild right now for them for version 12. They don't like to switch versions when I'm not on staff. I don't know, but we had something written in 4.2 well before you could write any while loops that helped us out with our inside dimensions and our closet sections. And I think that script was something like, I don't know, 2,000 or 3,000 lines of code or something stupid like that, because we had to account for so many different like case opening quantities. When the while do loop feature was introduced, I didn't do this right away because it took me a long time to even wrap my head around it. But once I finally grasped how that how you can loop through and do more with less, I took that script and I condensed it. Well, let's see. It's still pretty big, but yeah, I think so. 824 lines. I'm pretty sure that it was like 3,000 or 4,000 lines before. So it's an ongoing learning process. You will never stop learning, and as they allow you to do more, you're going to spend time refining what you've written previously and improving it. So don't be discouraged with wherever you are, and don't fall into the trap of thinking you've learned it all, because you will definitely have to learn this just basically forever. And try to stay humble and try to learn from the other people on the forums, really and truly. Again, there are some things about writing code that my brain does not like to do. I struggle tremendously with certain concepts, and it seems like some of you guys are able to just make this thing freaking sing, and it's impressive. So something to aspire to. So anyhow, this is like by far the longest stream I've done before. I'm exhausted. Thank you guys all very much for showing up. I'm probably going to be working pretty steadily over the next 2 weeks to build the next video for the UCSs. Anybody that happens to be here watching, if you have something that you want to get done, hopefully something fairly simple, but if you've got like a problem that you'd like to work through, I don't really mind. First of all, I don't mind kind of helping, obviously. If you want to just talk through it and you work through it, that's fine. But if there's interest, and I think that there should be, the next time I stream is supposed to be the last one of these that I do. But if we have like some good projects and good interest, I really don't mind doing a couple more that are really targeted to basically function like a workshop and work through some sort of like challenge that a shop might have. If we don't end up with a whole lot of interest in that like sort of realm, then I'm probably going to take just a little bit of a break. I'm probably only going to take a break of like one cycle of this, and then I don't even know if there's going to be interest in this next thing, but I'm kind of working on building a little homegrown ERP thing right now, and I'm doing a lot of learning, so there's not a whole lot for me to talk about or even share. But a couple of particularly capable, intelligent individuals have agreed to mentor me through this and help me out. And you guys all probably are well aware. I mean, he makes us all aware of him. However you might feel about Jonah, he is a very intelligent and capable individual for sure. And Jonah actually reached out. He's excited to be involved with the project, so hopefully he doesn't mind me sort of, I guess, name dropping, if you will. And then Classic Chariot also told me that he is more than willing to help me answer any questions. So I'm going to try to make a series based on kind of like my journey through building this homegrown ERP solution. And I'm going to really try to build it in such a way that it's also kind of like educational and helpful in terms of what we can do with the database information from Cabinavision, right? At this point, I've managed to get it exported and into Access, and what I'm hoping to make that next series about is the little bits of VBA that you will want to learn in order to be able to do what I'm going to try to do. And then it's just going to be this basic inventory management system where hopefully at the end of it, it'll be like barcode supporting, so that you can basically keep track of your inventory, right? It's going to be very, very simple and straightforward, but the idea is going to be that all of the additions would be done by receiving at an organization, right? As they receive the products, they're going to scan them into the system and everything. And then all of the subtractions from it, all of the requisitions for projects would actually be done by cabinet vision, not by a human. So yeah, QR code. We could do QR code for sure. So anyway, that's kind of like what I'm planning right now. I don't want to take a long break because, interestingly enough, it feels like this stream has a good amount of momentum right now, and we're actually reaching a lot of people, and I think we're doing a lot of good. So we're gonna try to continue this with like the next project that should follow suit really well with after the UCS one, and is gonna kind of keep us related to cabinet vision while exploring some different things that I don't know a lot about, but I've been told are apparently like way better than what cabinet vision natively supports. So yeah, there you have it. Thank you guys again very much, as always, for showing up and supporting and contributing. This would not be what it is without you guys. And hope you guys have a awesome weekend, and next couple of weeks I will be chatting with some of you guys on the forums for sure. And we'll see you guys next time.